All the claims I made to NASA and Yale were based on my research and my physical evidence. And this is a lung right here. Okay? And this also is a lung. They're in two different states of decomposition. This one still has all its pleura on it. The pleura is the coating, the rubber bag. This one transitioned into silicon primarily. And that's what happened because the oceans were super saturated with silicon. So what happened here, it actually pushed the blood out because the black pushes against the red, and the red is fluid, the black turns hard. It pushed the red blood out, and we actually had blood coming out. Now, this is the pleura. Right there is a little latch that holds that lung into the body. This is that lung. It's flat on the back because it died in the Great Flood. Now, I drilled down, when this first came out of the ground, it was just saturated with blood. I mean, this area right here, it's just saturated. So I cleaned it all up real good, and I drilled down into that, and the blood just literally came out as red raw blood. And I got the microscope cooking. I said, I got the microscope up. I'm going to show you right now. This is been so cleaned up that it's going to be a little hard to get much more blood from this area. But back here, I can get all the blood you want. I'll show you. It just turns into red raw blood. All right, so we're going to be doing this in the microscope. All right, so let's get ready. I'll show you raw blood from a stone. You see this? This is that lung. Now I drilled inside. This is just the surface. But look at this. This is literally just red raw blood. If I put water on here, it just runs into blood. You see how red and raw that is up in here? Now I drilled down inside. All right, but you see that? Look at this. You get inside there and it just starts bleeding. You see that? I'm going to dig down inside and it's just raw blood. It's just saturated with blood. Look at this thing. I got a coating of blood on the tip. You don't think you can get DNA out of that? Of course you can. Now, don't forget, I drilled down inside. This is the surface. That's the surface. That's what is, and I have blood in all of them, basically all of them. Now, the black does not turn into fluid. The red turns into fluid. The red is, it just never hardens up. It rehydrates very, very quickly. So you see the blood in there. This is some more bloody scabs that came out of some of the bones that I have here. They call it a bone foramen. And they come out right up in here somewhere out of there. And the bones have blood in them, and it leaks out through these little tiny holes. This was a scab. Just a regular scab. So I moved it a little bit. And what's underneath of it is the clotting fiber, what's called fibrin. This is what I can't believe. These people don't have any specialists there that can tell them, say yes, yes, yes. All I ever got was, I'm not an expert at this, I'm not. You're supposed to be experts. You've got a college, you've got 100,000 people hanging around here that should be able to give you some advice. Should have some doctors there. I mean, this is Yale. There's the black blood. You see the little tube coming out? That's the vein blood, and it goes to wherever it goes. And the red blood is here, and it goes to wherever it goes. This links the bones, the blood inside of the bones, because it's coming out the artery and back the vein. That's how it works. And they link one bone to the next. And again, this was before I drilled it. All right, that's where I took the blood out of. But you saw what I just got out of this thing here. It's saturated. It's just the other side of that spot. But this is where the real blood, you got a lot of blood in this area. Because that's the area that anchors Anyway, it's just saturated blood. You just saw it, so I don't have to go any deeper with that. Okay, my outstanding friends, this is Roger, Mudfossil University. We're going back about 10 years here to when I presented my work to Yale, and then I also presented it to NASA about biology here on Earth and in space. And then NASA, this goes back to January of 2016. And then, towards the end of 2016, NASA paid Yale to do the research on this soft body fossilization. And let me show you what I did send to NASA, specifically to Michael Zelensky. And I also specifically sent my stuff to Derek Briggs and everybody at Yale, a whole bunch of them. And didn't work out too good. Okay, my outstanding friends, this is going to be a little more serious than I normally am. I'm sort of joke around a lot, but it's kind of serious. I'm firing up the microscope right now. We are going to be looking at some emails that I sent to Yale and to NASA and so forth. And then we're going to be looking at things that are in space that I claim are biological. And this is what I sent to NASA in January of 2016. We're going to go through this email sent to Michael Zelensky. And strangely enough, after I sent him about the Mudfossils, Yale was commissioned by them, NASA, to look into perfectly preserved soft tissues, which is exactly what I sent to Mr. Zelensky. And they paid them, the NASA grants and all kinds of things. You'll see it as we go through this. But I had presented all my evidence to Yale years earlier with DNA and CAT scan specimens, the whole 9 yards. And it was pushed away, arrogantly. And I have all the emails to prove everything I'm saying. And so I turned to NASA, hoping that they, as scientists, would look into this. And I said, do not dismiss this, please, as a scientist. And I know they must have looked at this because that's my assumption. I don't know. Maybe I could be wrong. But NASA ended up giving grants to Yale. Derek Briggs, same guy I presented my stuff to, and he said, yes, this does happen, but only to slimy little creatures. We're going to go through this. Let me show you what I presented to NASA, because we got a serious issue right now with Asteroid Bennu. They refuse to acknowledge what it is. This is really serious. This is serious, serious stuff. So I'm going to be kind of serious today. A little bit of a departure. Okay, so now we come to Michael Zelensky. He's the curator of NASA Stardust, yada, yada, yada. He is both an astromaterial curator and researcher. And this is, apparently he's working with the University of Arizona. Now, I did contact him as well. He is a space scientist, NASA's Johnson Space Center. And it goes on and on about Michael. He's with NASA, and I sent this stuff to him too. I sent him the same thing that I sent to Derek Briggs before Derek Briggs got paid by NASA to do the fascia-facilitated fossilization, which he calls exceptional preservation. This is Derek's paper right here, Exceptional Preservation Soft-Bodied Creatures, promoted by silica-rich oceans, platypolar silicates. This goes to 2016, November of 2016. Well, let's see how this progressed. Okay, this is NASA. This is NASA, our space administration. I sent this to Michael Zelensky back in January of 2016. Now, this is 2016. Here's how it reads. Hello, I am a fossil researcher and specialize in anatomical biomolecular mineral and metal concentrates in certain types of soft tissue fossils. Tissue is preserved by spontaneous natural earth potentials, which is actually nucleophilic invasion, in wet soils that actually plate some mud-encapsulated creatures, platypolar silicates, that are in continuously wet conditions from the Great Flood. This led me to understand chemistry, crystallography of rocks, which led me to the fact that some rocks have veins and arteries. Veins and arteries are very apparent, as veins have depleted Fe2, which is the black blood, and arteries are bright red Fe3, or it's Fe2O3. It's oxygenated blood. Also have evidence that meteorites also have these features with blood in them, as you will see in a video. Comet 67P is an apparent tendon enthesis. As a scientist, please do not dismiss this, please. I have physical evidence with multiple available specimens. These have had 3 DNA tests, 7 CAT scans, experts' chemistry, lab recreation of the preservation process, and documented and videos. Please contact me. Now, this was Michael Zielinski from the NASA, and I think he's with the University of Arizona, because they went to Bennu and picked up a sample and brought it back, and I'm going to show you that too. Now, this was 2016 earlier. This was in January 2016. I had already been through the whole mill with Yale and Derek Briggs, and that wasn't a good experience. And when I sent this to NASA, they apparently went to Yale and said, "Is this guy crazy? Tell us what's going on." And they said, no, it works, but it's only slimy stuff, and forget all that other stuff he said. Apparently, I don't know what they said, but they funded them to do my research, which I had sent to Derek Briggs, I sent to Zielinski here too at NASA. I see this as sort of not a good situation. So we have the paper to Derek Briggs, and he wrote his paper a couple of years later, 2016. Well, okay, so that's the process. I sent all this stuff to Derek Briggs. I did everything he asked for. He just rejected everything. And then they wrote this paper. And the only reason I can think of they wrote this paper and did this is because NASA contacted them, because I contacted NASA. And they sort of ganged up against me. And I sent all my research and all my evidence to Lydia Tarhan, this Hood, Drowser, Gerling, Briggs. I sent it to the president of Yale, to all of them. I said, why are you people doing this? Why don't you do your job? And it was just total rejection and just a dismissal and, arrogance. And the last thing I got from Derek Briggs was, why don't you find a geologist to look at your rocks? And that's what he did. He made this paper. And it's long and detailed, and it's just, but it's basically just a bunch of fluff. And it's because of, as far as I'm concerned, it's because of my research. I don't know if he can prove any different. I can't see how he missed what I said, and he took credit for this. So I don't see that as good. And this was, here it is touting on Yale News, we figured this out. Now they're talking about slimy creatures that lived in a warm, slimy petri dish. And there was no bones, no teeth, no nothing at that point for these soft-bodied creatures. Ediacara biota just means Australia. It's soft-bodied creatures. And he's saying that there was just nothing but slime all over the world, everywhere around the world, worldwide. But no, it wasn't just slimy creatures, it was giants, which I had presented to Derek Briggs, and the first thing he said to me, "Oh, what are you, some kind of creationist?" And I said, whoa, what are you talking about? And I was saying, many of them are outright bizarre, don't resemble anything alive today. Lydia Tarhan, I contacted her, same thing with her. And they want to understand how this all happened. Well, I told them how it happened. See, the Arctic here, they're rapidly buried by sand, no, it's mud. And a very quick, rapid, they drowned. This was the Great Flood. It was worldwide, 3 layers, red bed, gray clay, black cap. Can't be missed. Cannot be missed. And the research is supported by National Science Foundation. So all kinds of other grants here and there. NASA Exobiology Grant. NASA Postdoctoral Fellowship. Foundations of Complex Life at NASA. I don't know how much money they gave them, but apparently they funded it. And as far as I'm concerned, I should have been at least involved or at least mentioned about this, that Roger Spur discovered these fossils in Connecticut, right down the street from Yale. But Yale decided it might be much better to go to Australia and look for some slime and pretend that that's really what happened. Well, I have the 100% evidence. So I think, I don't know, President Trump was talking about scams going on in academia, and I think he's got a point. I guess I have to leave it at that and see if Donald Trump would like to engage. I have all the evidence, I have all the emails, and I mean, I got a lot of them, that they, and it goes from NASA to Yale to all of them. I tried everybody, but I understand why everybody else dismissed me. Because the first words out of their mouths was, "You're right down the street from Yale. Why don't you take it down here?" Peabody Museum, they didn't want to specialize in this. And I mentioned that Derek Briggs refused to engage. And they said, "Well, that's because you don't have anything of validity, so please go away." And that happened literally everywhere. I actually ended up going to, took a course at Johns Hopkins. Because of Stephen, I think this is Stephen Salzberg, I think is his name. He was involved in this ancient DNA, and I presented my stuff to him, and that was an absolute nightmare as well. So it was straight across the board, and that's why academia is in such terrible, terrible shape today. Absolutely horrifying what they did to the human mind, basically, and science has undermined its own ability to think. And this stuff is just crazy. And this I sent to Yale too, about light slows down. It doesn't stay the same speed. It's really ridiculous what we've been told. Academia is way out of control. All right, real quick and simple. This was from March of 2015, sent to Derek Briggs, because I was told I had to go through him to present my fossils. I had originally talked to Professor Berger at Yale, and he requested that I contact you regarding mud fossils. I'm working with wet, platy silicate mud rocks, platy polar silicates. And they were thought not to have fossils, I go through the whole process, microcurrents, the process literally electrical replacement, which is nucleophilic invasion of the original matter. I had everything done. I had the chemistry done, everything. Because Ca2 is so reactive, that's the bone, it's replaced quickly with percolates, and they turn into mudstone, but it's still the bone, and it separates on the fascia planes. And I went through the whole thing, and it says, see Mudfossil process on my YouTube channel. And I said it was rare, and it's not rare at all. But it is not studied, and therefore mainstream science doesn't understand it. So I asked if he would look into this, and I'd like to have him comment. And that's Derek Briggs at Yale, March 4th, 2015. So I shopped my stuff around for a year or more. This comes up to January 2016. So about a year or so, nobody would pay any attention, but I knew that NASA had things that were biological. So I sent to NASA saying physical evidence of life in some rocks Mine are DNA tested and are human. So this is to Michael Zielinski. I think he's still with NASA. We'll find out. I said, I am a fossil researcher and specialize in anatomical, biomolecular, mineral, and metal concentrates in certain types of soft tissue fossils. Tissue is preserved by spontaneous natural earth potentials. They're called telluric currents. That's what I thought at the time. There are other things at play that I have discovered. But anyway, I said tissue is preserved by spontaneous natural earth potentials in wet soils that actually plate some mud encapsulated creatures. Platy polar silicates, silica rich, that are in continuously wet conditions from the Great Flood. This led me to understand chemistry, crystallography of the rocks, which led me to the fact that some rocks have veins and arteries. Veins and arteries are very apparent. The veins are black, the arteries are red. That's the chemistry. Also, I have evidence that meteorites also have these features, as you will see in the video. Comet 67P also is an apparent tendinenthesis. Now, this is back in 2016, just January 2016. So, I said, as a scientist, please do not dismiss this. Please. Bold. I have physical evidence. I'm not just guessing. Multiple available specimens. These have had 3 DNA tests, 7 CAT scans, experts, chemistry, lab recreation of the preservation process, and documented in videos. All of this was sent to Mr. Zielinski at NASA 2016. It's almost 10 years ago. I'm going to show you exactly what I did send him, because I sent him, I sent him everything that I sent to Yale. Same stuff. So you say, well, Roger, what did you send to Michael Zielinski at NASA? Well, what I sent him here is Mudfossils by the numbers. And what does that mean? Well, it means this is the process. It is a long story, it's very interesting. Silicon, carbon, iron, and fascia is the preservative in mud fossils. It's the blood, basically, but silicon that bubbled up from the salacious ooze when we were almost impacted by Venus. Here is the wet mud fossil process. Wet soils create natural electric currents called telluric currents. Molecular silicates are primarily fine mud and clay. They can be tiny, platy, and polar, some as small as 2 atoms in size. Creatures buried in mudslides can be sealed anaerobically by cold, deep, platy polar silicates, which is mud. Flesh is highly reactive ionically in these wet natural electric earth currents. Nucleophilic invasion. Leachates from above percolate and interact with the buried creature's exterior surfaces. The chemicals in leachates determine a fossil properties. An example is opal, which is primarily blood. Natural or electroplating of the creature occurs as silicon in the skin bonds to its most stable form, becomes silicon dioxide, which is SiO2 and SiO4, amorphous quartz, and feldspars. This is all very exact. This occurs on a creature's surface, but inside remains preserved under extreme pressure due to the deep mud on top. They're mud impacted. Normal oxygenated decomposition bodies literally explode from the gases as they expand. Sometimes skin is degloved. It literally comes off as a glove. And I have fluids are expelled from weak areas and orifices, but very little is expelled in the mud fossils due to the compaction. Like this lung is exactly the same as it was alive inside. Now, as plating continues, the surface becomes more and more restricted until only the tiniest invaders can penetrate and bond. H2O and OH- become the primary invaders. OH- extremely reactive and destroys calcium and phosphorus in the bones. It just destroys the bones. This is why bone is hard to recognize. It turns into stone. In Mudfossils, it's hard. You can't recognize the bones easily. I can. I know what to look for now. All the deep earth forces and temperatures over long times created these mudfossil rock copies. The same forces cause organic matter to sublimate and release methanes, which is gushing everywhere now. All the fossil fuels depending on the source rock and conditions. In my specimens, it was unusual that the deepest earth rock was lifted to the surface in a terrestrial rift valley with horst graben faulting. This is the Triassic era right here where I am. In my specimens right where I am, and that's exactly what it is. Sometimes glacial tilting on the surface disturbs and disassembles the creatures along facial planes, and body parts appear, like this 2-inch hair follicle. Erector pili muscle, sebaceous gland, hair shaft, root ball, and the 2 blood vessels at the bottom, 2 inches wide. Now, all this stuff, this is what, I sent that to NASA. That's one thing. Now, what else did I send to NASA? This was my paper from 2015. So that NASA got both of those. Now, what else did I send to NASA? I sent them my DNA reports from 2015, all my DNA reports, all the way down, all the way down, all the way down, all the way down, all the way down. Excellent quality DNA obtained from 2 out of the 3 samples, and it was Homo sapien mitochondria. I extracted the DNA and sent it from samples, this is one of them. This was excellent quality DNA, and it was flush with blood. You don't scrub it from the surface. You drill down inside and take a very, very, first clean the heck out of it, then drill inside of it, using all the precautions. And he said it was just like, almost like blood. And I can scratch this. Whoops, you can't see that, can you? Oh boy, hold on. Okay, I did show you there's just a ton of blood in here. And all you have to do is scratch it a little bit, and the blood comes out, as I showed before. Watch. It's totally saturated with blood. So what did I send to NASA? All right, I think I showed you, maybe not, the DNA reports, and one of them was from that lung, just saturated with red blood, excellent quality, Homo sapien mitochondrial B and D loop, and these were all the CTAGs, certified lab, excellent work done, 2015. I presented this to NASA, I presented this to Yale and everybody else. All of them, everybody, but they refused it. They wanted me to go to Yale because they were supposed to be the experts. Well, okay, I'm going to try to breeze through this. In 2015, early 2015, these came in from the European Space Agency. This is Comet 67P. I follow this thing just as well as anybody in the world. And this is a blast coming out of here. And these little bitty ones are coming out all over, facing different directions. I sent this to NASA. I said, you guys got biology here. This is an artery. It's cooking. It's literally cooking as it gets close to the sun. That's why comets only dust off when they say they're getting hit by the solar wind. Well, it's not just dusting off. It's being cooked. It's close enough that if it hits the blood, and there is blood in there, that's an artery. These are little tiny blood vessels, and they're feeding the tissue that was up above here. And now this is the artery, because that's gigantic, and I have all the evidence to prove this. Space smells like steak. Look it up. It said space smells like steak. That's because it's cooking off the hydrocarbons out of the blood. It's from blood. Now this is what this thing looks like. You see that? That's a hip joint. This is the epiphysis, which is the outside ball of a hip. There, right there, it's the epiphysis. That's what's sitting on the outside. It broke right about here. And this, you can see in it, there's a hole in the back there. Now, how it got ripped out, I don't know. Where it came from, I don't know. Who owned it before, I don't know. Okay, interruption there, but this is what's out there. This ball attached to that stalk, attached to the bone, the femur, broke right here. Or some creature, I don't care what it is, it's some rotator type of thing with what looks like the exact same thing. And they break in a variety of ways. They can break here, they can break there, they can break up here. It's in a hip joint, basically. You see all these people getting hip replacements. Well, that's what they're getting. Now, this, like I say, this is 2015. I reported this to NASA, to that Mr. Zelensky, I'm sure it was. And I've continued to try to push this, but it's not just, it's like talking to a wall. And here's how big this thing is. This is Raleigh, North Carolina. That's a pretty good chunk of stuff. I don't care what you call it. I wouldn't want to be hit by it. Okay, I know what you're thinking, Roger. This is crazy. A hip joint that big that it would crush Raleigh, North Carolina into smithereens? I didn't put it out there. But I'm going to tell you what, in the ancient texts, they talk about these things happening and these gigantic creatures in space. It's there. I don't know what else to tell you. That is there. There's no question. They landed down in here on the neck. The European Space Agency was called a fleh lander, and they picked up samples and they tested them. Juliet and Kenneth, I think it was. And it's all biological. I think here it is right here. That's ions, Fe's. That's blood. These are hydrocarbons. That's decaying flesh, basically. It's 100% biology. And they admitted it. And I think I talked to some, I don't think I talked to them, but I think I did have emails back and forth asking things to somebody, and I think they did respond. I was a little elusive about the questions I asked. I didn't make any statements, because by this time I realized nobody's going to pay any attention if you start saying things. But this is what I sent to NASA. I said, look, there's blood inside of these meteorites. This is an iron meteorite. That's red blood. What's that doing inside of a meteorite? And why is this one here black? Because red and black is FeO2 and FeO3. And all of these different colored patterns here are because that iron meteorite smelted so much that it became like a ball of metals. And what happens when they all melt together, they flocculate. I'm not kidding you, that's what it is. And they attract each other, they flocculate, like a phlox. Now that one was so big that it melted completely. This is just a little one, but it is also a lung. Well, I don't know if that one's a lung. This one is 100% certain it's a lung. And that little tab on it, I'll show you the details in the microscope. And I think this might still have some catalase in there, which is one of the enzymes. But this is absolutely 100%. You'll see this. It's got all of the fascia on it. It's got everything. It just wasn't big enough to completely melt. I have other ones here, like this one here, stony meteorite. And I'm going to show you what this is. You're going to freak out when you see what it really is. And then I got this one here, which is another stony type meteorite. Let me show you something. Take all my little magnets off. Watch this. This is beyond cool. I talk about blood being able to rehydrate. When they come through space, the blood stays intact inside. You can see it stays red and it stays wet. Watch this. When this came through space, it cooked everything down, right down to the tendon anthesis anchors. All right, so it's down in the deep layer of the skin, all that's burnt off, but you still have the basement layer, and then you get into the fleshy stuff, and that's where the anchors anchor in. Now, this is an anchor. It goes down in here, and there's a little anchor ball. And this was a layer came out, and that exploded off. And I'm going to show you why it exploded off, because that blood was wet. Watch this. Let me come up a little closer. That right spot right there. You're going to see black here, because it always is iron banding. When you're in a body, it's black and red. You got black, and then you got the red. Watch when I put water on there, how quickly the red rehydrates. Look at that. That's because this was still saturated red raw blood as it came through space. It didn't dry up. You see the black in the center there? That's where the ball comes down to anchor in. That little strap held this piece, this whole strap together, and anchored through here into the mass there. And now that you see the red and black, I don't know if you can. Well, anyway, that's what it is. And you know, here's the vein and artery in this one. That's the artery and that's the vein. And that's just red raw blood. They come through space, they still have blood in them. And like I say, this still does too. You're going to see this in a microscope, and you'll see there's still blood in there. And this one was saturated with blood. I drilled a hole in there to try to get some fresh raw blood out of there. Nobody will test it. I know what this is. I know exactly what it is, because I have another one right here that didn't come through space. Identical to this one. I drilled a hole in there to try to get some blood out of there and see if I get it tested, and nobody will do that either. You see even the hook right there? I know exactly what this is. I know precisely what it is. And this one cooked off. This one didn't. This is a terrestrial one. This one is not. That came through space. We got some looking to do. Okay, I'm sure I showed you the iron meteorite with the blood in it and so forth. And this is a little iron meteorite, and it is a lung. And you're going to say, Roger, how can you prove that's a lung? Well, we're going to look at it in a microscope, and we're going to see the alveoli all over here, these little tiny holes. And I show you it's magnetic. It's, you know, pretty strongly magnetic, but it did not melt entirely like the one I showed you that had the blood inside when they cut it. This one was not heavy enough to combust, basically, like the other one, into a ball of molten metal. So it's kept basically its structure. What else did it keep? It kept a latch right there. All right, they all have a latch that holds them in, and it's this part right here, and it's this part right here, just like on this piece of meat that I have here. That's literally a piece of meat that's solidified. This is the latch. You see that latch right there? It comes down. That's what locks this into the next piece of meat, whatever it's locked into. And there's a couple of little fascia tubes coming out that nobody knows about that goes into the interstitium, which nobody knew about either until my paper in 2015. 2018, they called it the newest organ in the human body and the biggest, which it is. It's your lymphatic system, basically. It's a fluid-filled highway. Anyway, this is the latch. I am going to show you that latch on this lung. Whoops, you can see the latch on this lung. This lung here, it's kind of, this was torn off here, but you can see that it was here, but it just got torn up. Every one of them has, and they were all in the flood, which preserved them because of fascia-facilitated fossilization, which I now call mudfossils. And they were huge, gigantic creatures, and some of them weren't huge, and some of them were small. But like that's a huge hair follicle. All right, that's this. There it is right there. There's the hair shaft, obviously. That right there is the erector pili muscle attachment. So hair can stand up on it. This is where the root ball goes down, comes out down here. And those two little dots are where the hair papillae go down. And that right there is the sebaceous gland. It's 2 inches wide. It's a hair follicle. So you make of it what you will. All right, I just went and sprayed this down pretty good with water. Now, this is the fascia, the coating that has this fabric, this little white fabric on it. But that stuff cooks up, and you end up with the black stuff stays, and the white little flakes burn up. However, there's a few spots in here where we're going to be able to see those white flakes. Now, what's underneath this is all that. Those are all alveoli. This is another mud fossil lung right here. There's the big air intake right here. You see all this orange stuff? That's red blood. It's still got blood in it. But it's leaked all out in a terrestrial way. This cooked and literally exploded those holes. All right, they were wet and it popped, and you can still find blood in this. I'm going to show you. I have to put a little more water on there. But this basically is the same as that. All right, only this one just was devoided of stuff, and this one exploded the stuff out. But we will see the same fabric we have here on this. We will see the same alveoli that's in lungs. We will see the same latch that's on the bottom here that latches this into the body. Whatever body it was in, I have no idea. It's a little tiny thing. That's why they preserve. If they're small enough, they don't have enough impact and they don't absorb so much and to get so hot. They come through. And I have other ones, little ones, that didn't cook up hardly at all. But they're quite obviously meteorites. Stony meteorites. Actually, I call them bony. I have some here. I have one here. Hold on. I have to find it. But it's a bone, and the marrow in it boiled off and turned into iron. So you have an iron inside of a bone. Very, very unique. Now, we're going to look at this in a microscope. I'm going to show you that little latch, and that this stuff is all over. It's everywhere. And out in space, I showed you 67P. It's a hip joint. They just went out to Bennu, which is this one right here. Well, this is the thing. And this is from the university that they've been working with. I forget. Anyway, it's the same guy working with NASA. Boy, where is it? Boulder University. I can't remember where it is. Hold on. Okay, here it is right here. It's University of Arizona. Michael Zielinski, space scientist, NASA. Now, I think they should look at my stuff. Okay, my friends, unfortunately, I see the exact same thing happening again. Michael Zielinski from NASA and Bennu is a problem. I think he's working with this deal on Bennu. This is the National Science Foundation, Smithsonian, NASA, and they sent out to Bennu to pick up a sample. And they did pick up the sample, and here it is right here. They landed on Bennu, grabbed a chunk of it, and came back. And they are trying to understand it. Now, they've done samples on it, the testing on it, and it has 14 or 16 of the DNA signatures, the amino acids. There's only 20, and I think they picked up 16 of them, or 14, something like that. Then they found the phosphate surprise, these two layers of, these white layers here. And they overlay these blocks. So there's a layer of blocks, another layer of the white, a layer of blocks, so forth. And these little bundles here, I don't think they have any clue about these at all, and nobody's mentioned them. I understand what they are. And they're all over. It's not just here, the whole thing. Now, and then the phosphate surprise is phospholipids. I'll explain to you what it is. And these are what they call sarcomeres. You say, well, what are all that? What do all those silly words mean? Well, I'll show you what they mean. So they must have some kind of biologist or somebody, an anatomist, that can understand what heart sarcomeres are, and there it is right there. These are heart sarcomeres from a heart attack victim here on Earth. Those are sarcomeres, layers of phospholipids, which are the phosphates. These obviously have the DNA and RNA and the URACIL and all the rest of it in there. And these are clay, basically, which is exactly what they found. There's no difference whatsoever to what they found. And these are the blocks. Those are those blocks. And the layers are these layers. They layer over and under those blocks so that they can slide, because it's a muscle. So is this. These are bundles of muscle, and they're straps that pull like this. And they're made out of these blocks, which are sarcomeres, heart sarcomeres. So we've seen a heart attack victim here on Earth. We've seen heart sarcomeres with phosphate layers, same as this. This is what the anatomical look is. This just shows a tear, and then they should be like this normally. And then when they engage, you end up with this. Well, that came from a heart. This stuff right here. Only it was out in space. And what does it look like in space? Well, it looks like a heart. Here it is right there. And you say, well, that doesn't look like a heart. It looks just like a ball. Well, no, it doesn't. Not if you're a heart surgeon. This circle right here, that's a valve. It's a heart valve. So is this. So is this. Have to know what you're looking at. This valve comes this way. And I can prove, well, I can't prove it, but I can show it. You see that little strap and strap and strap? That means the blood can come this way, but if it tries to go back, these just clamp right in, and that's why it's called a valve. It comes this way, but not going back. This was just the opposite. You go this way, but you wouldn't be able to come back. Now, they got deep inside there because they thought it was going to be all rocky. Well, it wasn't. It's all dusty because it's covered with red blood cells. And they came back with the sample right there. Now, what does a heart look like? This is what hearts look like, and so does psyche. Psyche's another heart. You see, this is what they look like, and this is what happens right up here. There's a layer of red blood and blue, which is the vein blood, vein and artery, and they separate, and iron banding makes them go snap, and they snap right open, and it pops right off. The top pops right off, and they do it even in autopsies. When the bodies are stored for a little while, and they do an autopsy on them, because of the polarity, the hearts just fall apart. And here's what the vein, the valves look like, and here it is here. That is the tendon, tough. That's the tendon, tough. Now, this is the hearts and the heartstrings and valves and the ventral walls and the different arches and all that business. And this is what psyche looks right up here. This is the tendon. The different colors are the colors of blood, FeO2, O3, and the serum stuff. These are the valves. That's a tube coming out. This thing is 140 miles across. 140 miles. And that's why they're so interested, because this is all saturated with blood, which is almost completely made out of metals. Blood, once you take out all the moisture, you're left with primarily metals. All right, so you saw all the sarcomeres. Well, guess what? This is up on Mars. This goes back to 2014. Curiosity landed up there, sent back all these pictures. I knew instantaneously what it was because of the Mudfossils. These are sarcomeres, and they have just dusted off because of the dryness. There's not any moisture there to speak of. There's no rivulets. There's no drops of water have ever touched this in thousands of years. But you still have the connective tissue and the red wet stuff, which never hardens up. If you put water on it, just turn it into mud, red mud. But this does. That you put water on is not going to do anything. That's connective tissue. This continually over many millions of years, this is on Mars. No, it isn't. That was a creature was there and died. However long it took them to die, I don't know. But Mars was hit by Venus. And it hit right there. That's wider than the United States. And Venus shows the same marks, only opposite. This shows a gouge. Venus shows an electric discharge into Venus, and it took the electric field from Mars and the atmosphere. There's no atmosphere to speak of here. That's why they can't regenerate their magnetic field or plant life, because it was so devastated and everything was wiped out. If you don't have a magnetic field and an atmosphere, you're done, and that's the case. That's why it's the red planet. That red is not just red for nothing. That's red because it was at one time blood. And the things in space are saturated with blood. The astronauts come back from a spacewalk. They say their suits smell like steak and burning metals, which is what blood is. It's saturated with metals. Okay, I always try to go for the top guy in the field, and that's apparently Michael Zelinsky at NASA was that guy. And the field of study was oxygen, astronomy, mineralogy, chondrite, meteorites, astrobiology, asteroids. This is why I got a hold of him, and I said, you got biology out there in space, and there is just no question about it. None, zero. And even like the meteorites, I sent him all this. I'm going to play the video that I sent to him, along with all the other information I showed you about my DNA and, you know, all that stuff, specimens and everything, and the video. And I think it was incumbent upon him to look into this with the evidence that I had, to just dismiss it and then end up having Yale distort the information, basically, because it's the exact same stuff I gave to Derek Briggs of Yale, but he just distorted. So, oh no, it was sand and only slimy creatures, and we discovered it, not Roger. Well, I don't think that was real good. I think Derek might be in a little bit of trouble about this. We'll have to find out how that plays. But as far as Mars goes, it's the same stuff I just showed you on Mars. Sarcomeres. And here's the Mars Morse code and crab and all that stuff. Here's the Mars crab. It's nothing more than an artery. These are little blood vessels. That's a vein. These are more sarcomeres, which is feeding the blood into these chunks of muscle. All right, and then also you got the Mars blueberries right here. These are identical to the to the Moki marbles out in Utah, Arizona, Nevada, because that's nothing more than a creature skin as well. There is nothing but biology, my friends, and to just run and hide from it is not. It's just, it gives a bad feeling. And here you are, you want to spend $11 billion to go pick up samples from Mars that they had collected, spending billions before, and left there. Now they want to go spend another $11 billion and years to go pick up stuff. We know what it is. There's no question what it is. Zero. At this point, it's just undeniable. Mars is 100% biology, just as is Bennu, just as is Earth, just as is everything. All right, if somebody wants to dispute this, that's what I'm waiting for. I have the evidence, not them. All they have is words. I have the evidence. They have, oh, we must know this. Oh, everybody knows this. Oh, we all know this. No, they don't. Everybody knows you can't get blood out of a stone. Yeah, nobody can get DNA out of a rock. Well, now they know that's all not true. And they're trying to wiggle around out of it. And the people that were didn't do their job should be seen as the ones that didn't do their job. That's all I'm saying. And I'm seeing it happen again, right up here with Bennu. It's just absolute nonsense to walk around in circles forever when you have in your hands what you know is a heart. And for them to be that incompetent that they can't understand that, we have the wrong people doing that job. Simple as that. And all the ancient texts wrote about exactly what we're seeing. Battles in the heavens. Mars being hit by Venus. Us almost being hit by Venus. And having a huge welling of the oceans, which created the three layers, the red bed, the gray clay, and the black cap. Worldwide. And all my mud fossils. I am in that layer. And all these mud fossils are in that layer. And they just picked them up. I just picked them right off the ground. Very little digging to do here. And we have to start to walk in truth and reality. All I ever hear is truth, social, we want truth, everybody wants truth, we're searching for the truth. And I find exactly the opposite of that. Exactly the opposite. Anybody that has an opinion, I don't care what it is, on what side of the coin, they're going to stay there. Doesn't matter if it's true or not. And then when you show them the evidence, doesn't matter. I call PhDs, they say it was all pareidolia, you're seeing things that's not here. Yes, I am. I'm seeing things that are here. Chemical, everything. Anatomy, blood, the whole 9 yards. PhDolia is a whole different story. Pareidolia, you can see things that aren't there. I get them all the time. Oh, we can see this, we see this. I get hundreds of them. I am a material scientist. I know what I see, and I back it up with chemistry and every test. There is nothing I'm showing that anybody can contest. And then the rest of it I call PhDolia, which means you're perfectly happy deluded. Doesn't matter. I can't see that. I'm not an expert at any of that. I'm not an expert here. I heard that hundreds of times. And that's what Derek Briggs said to me. He said, I'm not an expert in this or that. He says, and his final words to me was, why don't you go find a geologist to look at your rocks? And I told his assistant, Morgan, Armand, hello, Armand. I said, boy, you guys are going to look like the biggest fools on the face of the planet when this is done, and it will be done. And he says, yeah, well, we won't be the only one. I said, well, that's true. But they are the worst, because they're the ones that set me up for everybody not wanting to talk to me. You know, it's like they close the gate, don't let the guy through, and everybody said, go to Yale. I mean, I'm serious. That was literally the first words out of their mouth. Yale's the people to look into that. And they didn't want to see it. I went to the state archaeologist. I said, will you please look at it? No, I won't. I said, you honestly won't look at it? Nope. I tried Dinosaur State Park. We have all the dinosaur footprints. I have a human footprint in Triassic rock. I said, will you look at it? Nope. I tried everybody, and they all, every university, nope, we will not look at anything like that. This is what it's become to an academia, and this is, I want this straightened out. You got to have this straightened out. You can't walk and make any sense of anything until you start with truth. When truth is dismissed, just because it's a little uncomfortable, then you just lost everything. You just lost your entire life. It's just a waste. When you just want to walk around in circles, make sure you get enough money to feed yourself, and you don't care about any truth, then I say that's a problem. And that's what I see right now. All right, I love you all. Let's straighten this out. This is nonsense. Absolute nonsense to be spending billions and billions of dollars and turning away from the actual truth. Not a good look. Okay, my friends, this is that little lung. It's iron lung, and there's that latch. That's the latch that would latch this lung into whatever body it was going into. Now these are just little magnets here. Show you that it's magnetic. I'm going to take those off. Now, what I'm going to do is back up out of here a little bit and then come in and look at all the alveoli and stuff. Let me put a little water on the latch here so you can see it a little better. Now, you remember the other one. There was all kinds of, just saturated with blood at the latch. All right. right, but then you get back into the structure, it's a different story. This is real floppy and red and gooey. Just like this right here, look. Same as that. That's the latch. All right, and every one of them has a latch like that, muscles, organs, everything to hold it in its position. That's the tab that locks it in. All right, and it comes off of the fascia. The surrounds it. Now, we're going to go back into the fascia, back in here, and look at the alveoli, these little holes, and the surrounding fascia. And you're going to be able to see, I'm going to find some spots on here that still have the little white flakes. There's a few spots I found that have a pretty good concentration of white flakes. There's some right there that didn't get burnt off. You see them here? This is all of that stuff is just, it's a lung. Now you see we got some flakes here. The flakes are easily burnt. The metal doesn't burn. The black stuff and the red stuff does not burn like the flakes do. The flakes are very, burnable. But you can see them. Let me just lock this in position. Hold on. All right, that'll hold it there. I got a little vise here. You don't see too many of them. They're hard to find. Usually there's almost none. But this is so small that they didn't all burn up. You see them? Originally, this whole thing was coated with the same stuff as the other lung that I showed you, which is this one right here. They're all coated with this originally. The same as like this one here. That's the same stuff here too as that. It's just a little eroded differently, and the one came through space is completely burnt off the white stuff. The white stuff is flaky. It's burnable, combustible. No, but we can see it. The rest is burnt. These holes are exploded outwards. They're not eroded, they've popped out. Here's some more flakes right there, you see it? Now, let me find something interesting to look at here. Hold on. Alright, we're going to try to get down inside here and see if there's any catalase still in here, which is the thing that eats up the extra oxygen. We're going to put your hydrogen peroxide in here. And wherever there's a membrane, there's going to be usually a lot of catalase. Now, this came through the atmosphere and cooked. You can only get iron from hematite when you reach about 2300, 24, 2500 degrees. So, did it destroy the enzyme? I don't know. I think I did this one time a long time ago, or one of my other meteorites, and I think I did find catalase. Let's see if we can find it in here. But the best place to look for is where there's a membrane. And I'm going to see if we can find a membrane. Hold on. Okay, I'm going to play around with the light a little bit, but here we are looking at the surface. This was cooked, and there's still some of those little fibers, not many. This is an entrance into one of the alveoli. Now, I'm going to dig down a little here. You see down in here? That entrance is into the alveoli, which exploded out from the heat that it got from being cooked. Now, we're going to put some hydrogen peroxide in there. And we may see some foaming. Maybe not. It depends. A catalase is an enzyme. Enzymes are not indestructible. And at 23, 24, 2500 degrees, they may have been just destroyed. We're going to find out. All right, so I am going to turn up the light just a smidge. All right, now I'm going to just flood this thing with hydrogen peroxide. I got to move the scope out of the way for a second. I'm going to put the hydrogen peroxide in there, and we'll see if we get a reaction. We may not. Give me a second. Takes a second to do it right. Here we go, back to here. Now, if we don't see any foaming and bubbling, I already see it. I already see it coming out. There's still catalase in there. It's going to take a second for that moisture to settle its way in there. But I can see the catalase is bubbling underneath. See the bubbles? Hold on. Well, maybe I don't see it. Yeah, I see it. Here's coming up now. It takes a while for it to penetrate. You see it bubbling up? Give me a second here. Let's get right down on top, because this is at the atomic level. This is literally at the atomic level. It's boiling off extra oxygen atoms. And I can see it doing it. It's very hard to see. You see the little white foamy bubbles? Hard to see, but you'll see them in a second. They're not as strong as I'd like to see, but you can see them. You see all the little bubbles? I may have to hit this a couple times. Sometimes it takes a little while for this stuff to work in. Don't forget, these things have been around for a long time. This thing was out in outer space, but I can see the bubbles are there. Let me try some fresh. Now let's see, I just put some fresh stuff in there. You can see it bubbling around. There's a spot up there. Like I said, this is not strong like you see regular fresh blood. But there's enough of it. That's not by accident. These bubbles are coming up from an interaction of having an extra oxygen and finding catalase to break it off. So from H2O2, it breaks it down to H2O, which is water. We can live with water. We cannot live with hydrogen peroxide floating through our blood. And you can see it's bubbling away pretty good over here now. See it bubbling away? Watch, that's a good spot right there. If I put more in there, I think that baby would start bubbling pretty good. So you don't see it bubbling everywhere. It's only bubbling where there's blood. See it? Bubbling all around where the blood is. Let's go with another hit on that spot. Because it eats up the catalase, hydrogen peroxide pretty quick. Look at it boiling up now. That's brand new stuff just put in there. Boom. Depends on how reactive the catalase is. But you can see there's virtually no question. That catalase is doing its job of breaking down that hydrogen peroxide into water. And it's pumping pretty good right now. You see it bubbling out there? See this one up here? This one's up here is, I think, better. See our little bubbles? So So I'm going to tell you right now, that indicates catalase is a biological. It's in plants and animals. It's everywhere because it has to remove these extra hydrogens. Extra oxygens. So instead of having H2O2, you end up with H2O1, basically water. I think I've made my case pretty damn well. And that's a meteorite. And here is blood meteorites. I showed it to you. There's just no question whatsoever. Okay, I'm just going to let this play. This is what I sent to NASA, which I just showed you in the emails. Hold on. I'm going to just play you this, which was what I sent to NASA, and along with all kinds of details. And the same thing I sent to virtually everybody. And I'm seeing the exact same situation happen now with Bennu. This is crazy. They came back in 2023, I think it was, with the samples. You go to 2024, and now we're into 2025, and they still can't accept what they see. And Bennu it's a heart. I just showed you that. This muscle sarcomeres and all this. And this is what I sent to NASA 10 years ago almost. I'm just going to let it play, and I'm going to leave it alone and not make any mention. I'll let it go to its totalness. But this is all the work I had done 10 years ago. And more than that, really. Okay, this is a meteorite. And this meteorite is an iron meteorite. And you see all this crystalline structure when they cut it in half. This is what it looks like. Now, you see that black spot and that red spot? I'm saying that this was a part from a creature, and likely a lung, which is saturated in blood. Now, that is a red arterial vascularization, which means it has the oxygenated blood, which is FeO3. It has 3 oxygens. Now, once that stuff uses all of its oxygen inside of the tissues, it comes back black. And that's a vein, and that's the FeO2. And it only has 2 oxygens. And so it's black and red. And it's fully understood. This is nothing that I'm making up. Totally understood. You break a bone and you injure a vein, you're going to have black, and the bone has ferritins in it, which are black too. So the black is fully understood. The red is fully understood. Nobody can dispute this. And the chemicals are here to prove that as well. And they just have to be looked at. Why would this meteorite have a black hole, a red hole, a vein, and an artery in it? It was alive at one time. I don't know what it was, a lung, a liver, a leg. I don't know. I have no clue what it was. But I can tell you what happens is when it comes through the outer space and it enters into the earth, and there are these iron ones, I think it's got to be from a lung, because the lung is 100% blood virtually. Now, what happens is it came through the atmosphere, it smelts it, just like they put it in a factory furnace, and it blows off all of the organic stuff. It what's called sublimates them, it volatile vaporizes them, and what you end up with is the heavier metals and so forth, and this is trapped inside that matrix. And these crystals are all the result of other minerals and metals that were inside of that blood matrix that have crystallized, and they all have their own little crystal shapes, hexagons, octagons, yada yada, this and that, triangle. Anyway, they end up crystallizing on the crystalline form of their basic structure, and that is why you see all this, spectacular looking stuff. You see that? That's not just a rock, that's a lung. That's a lung. And you see inside there? That's where all the red blood is in the lung. And that's why when they come through the atmosphere and they smelt, they end up turning into iron asteroids. That's blood. Now, when in here on Earth, they start to crystallize too. When the holes, hold on a second, I'll find one with a crystal in it. All right, here's one here. You see it? That's what happens. Those are called vugs. And the metal seeds that are left over after this stuff would sublimate out of here, because eventually all that stuff goes away. You end up with these holes, and these holes start to grow seeds of crystals. All right, here's a bone. This is a bone. You look at it, so it's just a rock. No, it isn't. It's a bone. And when I fracture it open, you can literally watch the blood flow. This is the arterial side bringing the good blood in. As it's used, it starts to turn blacker and blacker and black. And by the time it gets over to the vein side, it's as black as ace of spades. You see it? You see the bottom there? I'm not making this up. This is reality. And I mean, I'm looking at this, and I can actually see the blood coming in, being used up, and getting ready to come back. So it's life. And it's, you go out and break out, open your own rocks. Every rock that you're going to find was alive. Case closed. Here's another one. You can literally see the blood. Here's the blood coming in, the nice, clean, fresh blood. The guy wants to run around and do things. Here he goes into his muscles or wherever is in there to say, okay, let's use up that oxygen, because oxygen is what does the work, or well, it's needed. And then it uses it all up. See, it's turned from FeO3, and it's sucking off those oxygens, and now you're down to FeO2, as black as ace of spades, and then it heads back up to be reprocessed. And the veins don't let it leak. That's just it. That's what it is. All right, this is the Achilles tendon, and it's from Zaro et al. 2009. I mean, I can't really find out who the author is, but I appreciate being able to use this. I hope I can. Now, this is the Achilles tendon, and this is in your foot. And you see these fibrous stalks coming out of this? That is what I'm saying is a similar, it may be the Achilles tendon, it may be a different tendon, but this is the architecture of certain tendons. They have a ball, and then they have these tendinous fibrils coming out, and they're very, very mineralized. That whole thing is extremely spiky and mineralized and hard. And as it transitions out of here, it goes into the flesh. When it hits the flesh, they transition, and it's literally it's like a step. It's unbelievable. I'll show you what it looks like. And it steps off, and then the muscles start, and that's where they break. Now this common 67P could be an Achilles tendon or some other tendon similar, but I have the evidence to show that that's exactly what it is. It's a tendon. All right, this is from min6.blogspot.com, and this is at 67P again. This right here is the spiky plagioclase tendon ball emplacement, and the bone would be like right up to here, and this is the stalky. You know, there's no sense to show every little bit of this. You've seen all this stuff before. This is what I sent to NASA. I'm just going to jump through. I talked about this. And then I talked about this here, and all the tendon stuff, and all the muscles and everything, and I went through all the little details. And then my own specimens I have here, there's a bone there, and then so forth. And I show this stuff over and over and over, and then this is the tendon that's in the bone, this is in the muscle I have here. And that's the muscle fibers, and they break off as they turn into sarcomeres. And I get a little long-winded. Here's that sample here, and that's where the sarcomeres are. The bone is here, the tendon, abrupt transition, muscle. This is that one that I showed you had all the blood running out of it. Or was blood, that's a meteorite. It's cut. What do I got here? Oh, there's another meteorite. Then I'm showing some of the blood that actually ran out of some of them. There's that muscle again. Well, this is almost 10 years ago. And then I did some samples I made. You know, I actually made some Mudfossils myself. I'm showing how bones change. And then this thing here, hold on. Of life, and you got to come down to reality. Open your mind up, or you're going to take it out and throw it on the ground. You got to get your mind so open to understand this. But that's the facts. So let's deal with facts, and then we'll come up with the answers. That's all. You can't get answers from putting your head around and not looking. All right, if you can handle reality, here's where you're going to find it. Mudfossils.com is... This was my original site. It was destroyed. Totally destroyed. Finally, I just shut it down. And they just hammered the hell out of me. I had all of these things all done. I had, I think, 40 or so videos. I got 100 hits, 150 hits. I was put into a box, and I've never been able to get out of that box. Never. I show all of these, one right after another. As a matter of fact, let me show you what apparently, I don't remember showing this, but let's see what it says. Here's where you're going to find it. Mudfossils.com is my YouTube site channel. Now, I have all the evidence here. It's unimpeachable. No question what I'm saying is correct. And if you will go and look at it, you will have to make your own decision. But if you look at it, I think you'll find that it holds up. There's nothing here that can't be held up. And I have all the information, how tendons are formed and how blood is worked and how the plagioclases happen and how people have been maligned in the past for coming up with ideas, like Velikovsky, very, very smart guy, destroyed. Manly Hall, destroyed, smart guy. All of this stuff, I have all of the documentation. I have over 150 videos. You don't have to, and this one, I have all of them. Stonehenge. Stonehenge is a giant. It's all pieces of giants. So anyway, that's, you should go to my site and look at this stuff, because there's no way that you can not. I had 150 videos, and they collapsed the site, destroyed it, so I finally shut it down. I started up a year or two later. I don't know. I can't remember now. This goes back. But the key is that all of this stuff was done and just refused by the people we trusted to look into things. I don't think that's right at all. Not right whatsoever. And I see it happening again with Bennu, and I don't think it's ever going to stop. And I have been trying to get a hold of these people, the people that are in charge of the Bennu operation. I've been emailing, nothing again, same stuff. Okay, once again, my friends, Dante Lauretta, principal investigator at the University of Arizona, is in charge of curation and scientific analysis of the returned material. I believe NASA Johnson Space Center principal investigator, University of Arizona, is Dante Lauretta. Now, I tried contacting Dante Lauretta here, and I sent all my information. This was 24, no answer. Then I sent again saying, "Hello, sir." I don't know if it's a sir or a her. I have no idea. But anyway, I said all about this. I said, it sounds insane, but these are hearts, and you have the stuff in your hands, and you can prove it right now. And I'm saying, I have all people that work with me that support the things that I say. And nobody's dismissing, they can't dismiss this. They can't dismiss this. And then once again, I said, look, this is serious. These are the attachments. Still nothing. And these are the lead investigators. Now, I see this just happen over and over and over again. And it's not just this one. It's not just this one or that one. It's just straight across the board. Fermilab's the same way. We accelerated light using a cheap laser, and we found exactly the same particles they found at CERN and Fermilab and everything else. Refused to engage. Blocked, actually, and called names by their top researcher. And I ended up going to the University of Geneva, and I showed them our work using CMOS, which they refused. No, you can't see it with CMOS. I said, yes, we can, using smartphones. You can see it. You can see these electrons, muons, electron neutrinos, showers, all of that. No, it's impossible. I said, no, it is very possible, and we're doing it. And sure enough, now they agree it is possible, and they upgraded CERN to use that. I'm not kidding you. See this? I said, can CMOS phones see electrons and muons? Yes. Complementary metal oxide semiconductors, including those found in phone cameras, can detect both electrons and muons. We've been doing this for 10 years. And they say, oh, no, you can't do this. And I was really assaulted by Don Lincoln, the guy from Fermilab. Still am. I'm blocked. I can't talk. And we found the exact same particles they found. And now they're doing this deep underground neutrino experiment. Billions. I mean, I can't even imagine how much money they spent since 10 years ago when I showed him the particles from our experiments, and we can get them today. And we may even be able to get free energy. All this stuff is rejected by the people we trusted to work with us. A citizen scientist, which I am, is no different than a regular scientist. I just used a citizenry who has been rejected because of peer review. And they're the ones that have the evidence, and it's rejected by the people that are just too arrogant to look at reality. They're PhD'd. They have PhD-olia. Unable to see the obvious. All right, thank you. It's got to stop. It's got to stop. We're spending billions and billions and billions of dollars in Yale. I think we should, they should be able to fund my school because of what they did to me specifically. That's, and I don't know, a few $1 billion probably do it, 5 maybe. And the rest, I don't know. They got $40 billion, I know that. And I don't know, maybe the government's interested in some truth and reality, and see it's not coming from there. Maybe that money could be used somewhere else. Who knows? I see that could be a possibility. I only want 5. 5 billion would make my university worldwide free and truthful and open and a forum. And we need some sophisticated interaction platforms. And I know Trump and all the rest of them are doing this kind of stuff now. They're making their own little social platforms. But let's make one where people can present their evidence. And we can have little chat rooms. One guy will say, I'm talking about physics, I'm talking about Mudfossils, I'm talking about history, I'm talking about this, ancient texts. We got to start off from brand new again. And the only way we're going to do it, the only way, is to have chat rooms open where everybody can talk and be heard. Because if all you listen to is me, well, I can be wrong. I know it's kind of unlikely. But it can happen. Okay, my outstanding friends. As you know, if you've been following me, I have been railing against peer review and academia for many, many, many years. And now they are finally tumbling and collapsing. How the scientific community undermines its own trustworthiness. They realize they're in trouble. Okay, public trust is collapsing for science, and the leading spokespersons for science are complaining about the decline of public trust. Well, in their craft, the leading spokespersons for science are complaining about the decline of public trust in their craft. They don't need anyone to explain why this is happening. It's obvious. Their own journals contain the evidence. It's time for a scientific revolution, an ethical revolution. Go back to ethics. Go back to honesty. Scientists need to clean up their act, listen to their own confessions, peer review, the collapse of collapses. You see this? This is the collapse of collapses. They had control over the entire society. They allowed people to speak or stopped them from speaking. The alleged lack of peer review is used to bash. Complaints against the practice have been increasing in intensity in the last 2 decades. We reported this last year, and it may be beyond reform. It is right now. There has to be some serious intervention here. Okay, I suppose that is enough for today, but I'm telling you, we got to start from scratch, my friends. And we're going to have to kick and scream to get this done. And we need somebody that's got some power. Because if you think there's power somewhere, you go behind those ivy-covered walls. That's where the power exists. If you speak up, they will destroy your life. If you don't have a piece of paper, then you're not worthy. So you have to work in the fields. They give you a piece of paper if you give them a whole batch of money and say precisely what they tell you to say. If you deviate from that words, then you'll be downgraded or failed. And they'll keep your money and they'll tell everybody you're an idiot because you couldn't repeat what they said. Very, very tragic situation we find ourselves in right now, my friends. All right, love you all. Thank you. Bye.